So let's jump into this evaluation store because that is something, it's a new term I know that is being coined. And I want to know what it is. We should probably start with what it is, and then we can get a little bit deeper into it.
Sure. Yeah. So the insight came from, I was thinking about like the life cycle of a machine learning model, right? And I think maybe actually just even taking a step back, I think the way, like to me, one of the fundamental differences between, machine learning research or even like production machine learning in the sense that like you're using your models to help do analytics, right? You're training a model that's going to produce some predictions and you're going to make, and then a human is going to like look at those predictions, use them to make decisions. The difference between that and what I think of as production machine learning, which maybe another term for it is like data products, right? So it's machine learning systems that are being used in the loop of a product or service that your company offers, whether it's internal or external facing, and is making decisions autonomously or semi-autonomously, but with kind of a tighter feedback loop than like an analytics-driven machine learning model. So that's kind of what I think of as production machine learning systems, these like data-driven products that have predictions in the loop. And I think there's a few fundamental things that make building those types of systems more challenging. One of them is that you often need to be able to run those models in real time. The data distribution that you're evaluating the model on is going to shift from under you. And it has, in many cases, it has a long tail. And so you can't really assume that, like, you can't make an IID assumption like you do in academic ML. And on top of that, like, you need to be able to handle the fact that you don't always have a really tight feedback loop from the people that are making decisions based on those models' predictions. So those models need to be able to operate on their own and be able to alert you when things are going wrong. And so thinking about kind of the infrastructure that companies have right now for building these systems, there's one of the interesting things about the machine learning infrastructure world is that there's a lot. There's just a lot of stuff going on right now. And I think like a lot of people look at it and they're like, what's happening? Like, why are there so many tools in this space? And it's just so messy, right?
It's a great way of putting it. There's a lot.
There's a lot. But the thing that's really funny about it is that when you talk to people who are like just actually out there in the world trying to make this stuff work, they're kind of like, yeah, I guess there's a lot, but I don't actually have any tools there's not that much that I use or that I get a lot of value from. So just trying to like figure out what the gap is there. And one of the things I noticed is that like in this world of, models where your data is continuously evolving and you need to retrain your models and and your models are operating on these messy distributions. And so it's very, very hard to be certain about like the model's predictive performance. What is actually needed in order to make that work? And I think when you think about the life cycle of a machine learning model from, training it to testing it to deploying it, monitoring it, collecting data that's going through that, labeling a subset of that data, and then retraining your model on the data that you label. The one piece that is basically the way that I think companies should think about making decisions about moving models through that life cycle is by having a robust understanding of how well the model is performing at each of those stages, right? So when you're deciding whether to promote a model to production, it's kind of this testing question that we were talking about, right? Like, how well is my model performing across all of my metrics, slices, and data sets that I care about? And then is that performance, am I confident that that performance is actually better? And then when you deploy a model, since you can never really be totally confident about offline evaluation, making sure that you're able to run A/B tests and run models in shadow mode and get some like live evaluation of the models before they start eating all of your production traffic. And then for monitoring, it's kind of the same question, right? Like you want to know how well, like given this new data coming in, how well should I expect my model to be performing on that data? Like, is it, does everything look good, or is there like some degradation in performance or some like something unexpected where I just don't know how well it's performing? That's kind of the monitoring question. for what data I should recollect, you should, most people just randomly subsample data, which makes a lot of sense. But, it turns out that like in these long tail distributions, randomly subsampling data is really inefficient, and you can subsample data all you want, but you're never actually going to get the data about the edge cases that you care about. So deciding what data to recollect is also a performance evaluation question, right? Like you want to collect data where the approximate performance of your model is low or maybe uncertain. Labeling is the same thing, right? And then ultimately, like closing the loop when you want to decide whether to retrain your model or not. Really, in a perfect world, the way that you'd make that decision is just an ROI decision, right? It's like, okay, is the expected gain from retraining my model greater than the cost of retraining the model? And it's really hard to approximate that. But at least if you can have an understanding of how much your model's performance has degraded in production, then you might be able to like start to get at proxies for that question. And so that was kind of like the core insight, is that at each of the stages along the life cycle of a model, the kind of the operational lift is, there's a lot of like pipeline stuff and sort of data piping that needs to happen. But the core decision that humans need to make should be informed by the question of like, okay, do I have a good understanding of how well my model is performing at this stage so that I can continue to move it along?
So it's really analyzing in each stage of this process. You're analyzing it, and it's a human that's analyzing it and saying yes or no, like we can move it forward.
It doesn't have to be a human. I think over time, a lot of these things can start to be automated. But I think, right now I think my near-term, like medium-term mindset on like how machine learning systems are going to get created is that it's still going to be, there's still going to be humans involved, but those humans are going to be involved at are going to be made a lot more efficient by tools, and the surface area of what they need to do is going to be reduced to looking at data and looking at model performance to a large extent. And then over time, like some of these steps will start to, our methods will get better and the tools will get better, and we'll start to be able to automate some of these steps. But I think it's going to be a long time before you really remove humans from the loop from most machine learning systems.